Yeah, so this was the one. Hi, everyone. Today it is my utmost honor, to call my master to share our learnings. And I was specifically more interested to learn more about her uh, takeaway, mostly on how to handle errors, because some of the techniques which I really learned from her, either by watching her webinars or the Global Excel Summit, or even her previous videos on Enterprise DNA, I learned a lot, and it has helped me in my life like anything. And to debug those queries, specifically the debugging part, that has saved a lot of my time. And if I count my time, I feel like I've watched lot of Naruto videos thanks to her. So that's why I was really really interested when I really wanted to call her to speak on how to handle errors in Power Query. But let me tell you, how did I first meet her? We first met, I think, mostly on Excel BI challenges 2, 3 years back, if I remember correctly, when I first watched her how she solved the Power Query, the Excel BI challenges with MCOD, and I really became a good fan of her. And when I would have dinner or whenever I got time, I used to binge watch all of her videos on Enterprise DNA, even if I understand or not. But I always knew that, see, Aditya, if you grind these videos now, I'm pretty sure that you are going to learn a lot from her, and you will be, when time will come, you will quickly implement those techniques the way she teaches her. And I will tell you one of her ideas, because what happens is, again, I also get into troubles. And this was one of the queries when I recently asked Melissa that, Melissa, I'm getting into a problem where when I do the running totals in one of the query, right, the problem is coming that the headers are not taking those change type, So it was creating problem. And she came up with such a simple solution for which I spent 4 hours to think, okay, how can I solve it? She solved it in, I think, pretty much very fast in 1 hour only. And the techniques she used, I really became again second time fan. So that's the thing. She always pulls a lot of good stunts whenever it comes to Power Query. She has got one of the immense knowledge, and she has become my go-to person whenever I get stuck in Power Query. And again, one of the you can say that one of the greatest contributions he has done is the definitive guide to Power Query book. Because when I thought that, okay, I have learned Power Query and what more I can learn, right? But when I read this book, the 1600 pages, I learned techniques like short circuit technique, the more about the variables part and everything. Yeah, I am very happy. You can say that I am immense blessed that I was born in an era when she has written this book. So it has helped me a lot to write more good Power queries. And again, I know you guys already know her, but you guys can connect her on LinkedIn and GitHub as well. So I'm going to check more of her GitHub queries now to see her about the date query part. I think, if I'm correct, she has published there as well the date query part to build the calendar query. All right, Melissa, the stage is for you.
Awesome. Well, I was just wondering if you should stop right here, right? Because this was awesome. Okay, let's see if I can share my screen. There we go. So tell me if you can see that, please.
Yes, your screen is visible. And
Awesome.
others, will do you please mute yourself so that there are no disturbances in the session? That will help.
Perfect. Okay, so let's get to it. First of all, I want to thank everyone for being here today, because let's face it, I'm always surprised when people turn up for a session with a title like this: error, Power Query. Those are words that can trigger cold sweats in the best of us. But I'm glad you're here, because, well, the chances of running into an error in Power Query? Well, I estimate those at a whopping 100%, guaranteed. Now, if you're new to Power Query, don't let that scare you, because, well, errors are simply a part of the data preparation process, especially when working with unstructured and, of course, real data. So, briefly about me. I'm Melissa de Korte, and I love sharing what I've learned about Power Query and especially the M language. For nearly 10 years, I've been active in community forums, answering questions, sharing solutions, and over time that grew into other content as well, like speaking engagements such as this. I'm honored to be a community super user, Microsoft MVP, and of course, co-author of the definitive guide to Power Query M. And some of you may also know me from LinkedIn or from the code that I share on GitHub. So on this slide, you'll find 3 QR codes. One takes you to the book if you want to check that out. One to connect with me on LinkedIn. And of course, the last one to my GitHub gist where I share code samples. So as I was preparing for this session, I asked myself, how do you make a topic like error handling a little bit more approachable? And then it hit me, right? Error messages are a lot like toddlers. They're extremely hard to understand at first and brilliant at testing your patience. But once you figure out what they're trying to say, they also start to make a weird kind of sense. And data, well, often that behaves like a toddler too, unpredictable and capable of creating all sorts of chaos. So what do? We baby-proof. Just like you'd cover an electrical outlet or place safety gates at home, we can baby-proof our queries, anticipating where problems might occur and put some safety guards in place. Now, if there's one thing that I hope you will take away from today, it's this. Queries need baby-proofing. And during this session, we'll cover 3 things. What is an error? Just some strategies for debugging. And of course, we'll try to get a handle or a 360 view on error handling. So by the end, you'll have a better understanding of what errors are, know where to start debugging, and of course, to make your queries more resilient. Now, will you learn everything there is to know about errors in just 1 hour? Not a chance. But you'll have enough knowledge to boost your confidence and start seeing errors as learning opportunities instead of something to fear. So let me tell you a story, right? Because earlier this year, I gave a presentation on this topic at the Global Excel Summit in London. And to prepare, I came up with a game. So I set a timer for 2 minutes. And I challenged myself to create as many different errors as I possibly could within that time frame, without any prior preparation at all. And this was the result. So I'm afraid that this is going to continue for a while because, well, there are just so many different error messages. And that alone, of course, considering that, it's no wonder that most of us feel overwhelmed or even a bit intimidated by them. But here's an encouraging thought. When I look at these errors, most of them can be baby-proofed. And that's important, right? Because the real goal is never to build the perfect query, but it's to build a resilient one. Queries can fail, and sometimes that's precisely what you need them to do. But the simple truth is this, right? Every expression can only generate one of 2 outcomes. It either produces a value or it generates an error. So what is an error? Well, an error is a special value, at least according to the documentation, that's generated when the evaluation of an expression can't be completed. Now, once an error is raised, the error is saved with that specific entry. That means that every time you try to access that value, the same error will be shown. So it's not reevaluating that expression, right? It's just showing you the result of the previous evaluation. So often we only see a notification, right? Something that looks like what I've got depicted here. But where's that information coming from? It's coming from an error record that was generated. And usually that contains at least these three items. A reason, so it's telling you why it failed, a message that describes the problem, and of course details, the values that were involved. What's good to know is that we can also access these error records. And that's really useful if you want to set up exception reporting, for example. Then you can extract information from it. I'll show an example of that later. But above all, it is our job to interpret this information and take appropriate action. So let's say, God forbid, an error happens. What's next? Where do you even start? And the good news is that all errors can be divided in just two categories based on what we see happening. So it's very clear. The first group is errors that break your query. These are often referred to as step-level errors. Now, when they occur, you immediately know there's an issue because your query simply won't execute. And then there are errors that don't break your query. Those are also referred to as cell-level errors. These are more quiet mischief makers, right? Because your query will still run even though there's a problem. So let's stop with the theory and let's head over to Power Query, right? And I'm going to kick things off by exploring step-level errors. And I'm going to discuss the three most common ones: the data source error, a syntax error, and an expression error. So here we go. So let's talk about step-level errors, right? Now, the first thing I think you need to be aware of is the debugging strategy for step-level errors in general. And it's very simple. First, you have to make sure that the query settings pane is visible. So when that's not the case, that's that thing here on the right-hand side. When that's not visible, just head over to the View tab and you can toggle it on right there. When that's visible, you would turn to the applied steps and you would either start from the top or the bottom. I usually go top down. You would select each step until you hit an error. And that's the breaking point, right? That's where you need to start your investigation. Now, when you make changes, of course, verify that any change didn't introduce a new error further down the line. That's always good practice. When considering or speaking about data source errors, right, it's good to check the availability of the source itself. Just imagine if you're connecting to a website and that website is down, then it makes perfect sense that your query fails. However, more often there's an issue with the connection string, the path, or the file name. I mean, maybe a file got renamed or a database moved, but in all those cases, you can expect a data source error to make an appearance. Typically, of course, these are tied to the first step in your query, as we've already seen right here. So while you may not be able to prevent a data source error to appear, you can make it quick and easy to resolve. And that's by using parameters, right? Now, that little change in query design can have huge impact on future maintenance. Just think about it. Most of the time, we're connecting to the same source multiple times. So instead of updating every single query, now we have to manage that connection string in just one single place. And that makes all the difference. So how do you set up a parameter? And I'm going to demonstrate that in Power BI, where we actually have parameters right here. So I'm just going to select the bottom half and select new parameter. This dialog box shows up and you can give the parameter a name. That's the first thing that you need to do. Make it something that is applicable, of course, to your source. That's the first bit of advice that I want to give. And the second is try to omit spaces and try to omit starting them with a number or a special character or anything like that. Just regular text. I usually type my parameters in camel case, so that would look something like this. Let's do file path. Now you have that, right? Think about the next one. When relevant, please provide a description, if not for yourself, for whomever inherits your work. So please be kind to the people who come after you. Next, there's an option here that says required. Now, that's always checked by default, and it only means that a value must be provided and cannot be omitted. That's it. Leaving that checked is perfectly fine. You have to, in this case, provide a value for your connection string, right? So leaving that checked is wise. Type, that is straightforward. That's going to be a text. We're talking about a string that we want to provide. And next we have suggested values. Now, normally any value will do. You can just provide a string here. But when collaborating with others, think about using a list of values, right? When you pass a file or when you pass a development file between one another and both of you have stored a local sample file, then it makes sense to generate a list that you can select values from. Now, I'm not going to do this because I've already set that up, and I've set it up as a list of values. So there we go. So I got two values here for two locations, and I'm just going to leave it as is. So there we go. I'm going to press OK. So here is my parameter, and it's now got the there's no such file selected. I'm going to switch to this is the correct file. Of course, that won't actually do anything yet because I haven't implemented this in my queries. So now my parameter is set up. All I have to do is update the queries that are connected to that source. From that point on, of course, if anything changes to my source, I just quickly can update my parameter and all connected queries will be fixed. So here it goes. I go to the source tab. Here's my connection string that was generated when I selected my file. And instead of this, I can just call my parameter, the file location. Hit that check mark. There we go. Perfect. And I've got another query here. And again, just updating that once. Hitting that check mark. There we go. Now, if I set this back, of course, so if something changes, then my queries would break. But now, instead of having to go through all of my queries and update them one by one, I have that single place where I can manage that file location. Simply switching, and there we go. Then they're all restored. Awesome. So Aditya, are there any questions on setting up a parameter?
No, I don't see anything in the chat right now.
Perfect.
I hope everything is clear, not all clear, right? This is the only thing. Baljit is asking, will it be same for Excel? The things which we are doing, will it be same in Excel as well?
You can use parameters in Excel, but my advice for Excel would be to just create a worksheet input. It's about managing that value. So if you want to provide the ability to your user to update that location string, I would just create a space within my worksheet, bring that over to Power Query, and use that as a source instead of a parameter. So that will be a query, a named query, just like this. It just won't be of the parameter type, but it will be a query that returns that connection string. If that's unclear, I can perhaps demo it at the end, or you can connect with me on LinkedIn and I'd be happy to talk you through that. Anything else? Awesome. So let's take a look at the next error from that first group, and that's the syntax error. So a syntax error that happens when the M engine encounters something that it doesn't understand. To the engine, your code looks like gibberish, and as a result, it can't be processed. And it's up to you to figure out which tiny little detail, like an additional or a missing comma, bracket, operator, or something else entirely, caused it to break. That often feels like searching for a needle in a haystack and can be notoriously difficult to resolve. So, by the way, did you notice that there's a broken step indicator here in the applied steps? I've only known that to show up with syntax errors, but it's really, really nice because it will tell you where to start debugging, right? Anyway, I'll open up the formula bar so we can have a look at the code. So can anyone spot the problem? And this is more of a rhetorical question. I'm not going to put anyone on the spot, and I'm not even going to expect an answer because it is really, really hard to tell. So in the preview pane, it's trying to give us a clue. It's pointing to the right, so let's just take a look, and then it's pointing up, so it's saying, well, start here. Okay, so let's do, and I'll highlight that bracket. Now when I select that parentheses, right, I know and I immediately spot there's a misalignment. But this is not the culprit, which means I still have to comb through the code to track down the actual issue and fix that. In fact, because this was written as one giant nested expression, debugging became far more difficult than it needs to be. So let's take a look at my other query for the syntax error, because this has the exact same issue. The only difference is that instead of that giant expression, that expression has now been written as a let expression. And again, please note that the problem, the underlying issue, is exactly the same as the first query that I showed you. So let's take a look. In the preview pane, that's this part of the screen, right? It's another indicator that we can follow. So let's do that. It's telling us, look at line 4, and then from the each expression, it's telling us look up here, right? Now, I can immediately spot the issue now, right? There's a closing parentheses there, closing off this function. So there's an additional bracket there that's causing the whole thing to fall over. If I remove that and hit that check mark, all is good and well, right? So breaking your expression apart, making it more manageable, makes it way more easy to spot problems and to fix them. So while we're on the subject of breaking complex expressions apart into those more manageable pieces, here's another debugging trick, the record expression, right? And you can think of it this way, a let expression is really just a record in disguise. So I'll select this query and I'll open up the advanced editor this time, and I'll zoom in. Here we go. So this is a let expression. It starts with a let clause on line 1, and it has an accompanying in clause on line 6. Between them is a comma delimited list of variables with values assigned to them. In this case, all of those values are expressions. Now, the outcome of this let expression is determined by whatever follows its in clause. And in this case, that's the variable result. Now, if I want to review intermediate values for debugging, well, it's a bit of a chore. I'd have to replace results with another variable name and repeat that process over and over until I've checked all of my variables. Basically, it's peekaboo for your data, except it's a lot less fun. So let's close this and see if there's a better way using a record expression, right? So I'll open that and I'll zoom in again. This is the record expression. It has that opening square bracket on line 1, and it has the accompanying closing square bracket on line 6. Now, between them, we don't see variables with expressions assigned to them, but we see a field name and a field value. So they're just field names and field value pairs. But here's the twist. The outcome of a record expression is the record itself. But if we look closely, there's something else here. This is called field access or lookup. It basically means grab the value from that field. In this case, grab the value from the result field. If I comment this out, so I'll hold down Shift, Alt, and press the A key on my keyboard, I'm commenting this section out, and then now press Done. Instead of that one value that produces the error, I now see the entire record, and I can explore that. So I can see all of the intermediate values. I don't have to play peekaboo anymore. I can just check all of them, see where problems are, highlight them, right? And just start to resolve the issue. So this is a method that allows you to quickly inspect all of the values and start your debugging process, which is much more easy than working through a let expression, returning all of those values one by one. So just a trick to keep in mind, instead of a let expression, you can also switch to using a record expression. So now we've talked about two types of errors that are known to break your query, right? That produce step-level errors. There's one more that I want to call out because it's probably the most common step-level error, and that's the expression error. Now, the expression error shows up when you've named something that simply doesn't exist, like a column name, a step name, a query name, or maybe some other value, right? And in the error message, you will find a hint because it will contain phrasing such as column not found, name not recognized, or did you miss a reference? Perhaps key didn't match any rows of the table, right? Different wording, but they all refer to the same thing. We've named something that doesn't exist and that isn't there. We'll go through some practical methods for handling those scenarios a little later, so something to look forward to. So on to our second group of errors, the cell level errors, the ones that don't break your query. Well, to troubleshoot and to start debugging those, right, you need a little different approach. So when an error is contained, for example, within a cell, right, your query still runs. And the most effective way to start debugging is to create a reference and then keeping all of the errors. That will give you a sense of the scale of the issue that you're dealing with, if any. So let's take a look. So I've got a query here, and by the looks of it, it looks pretty good, right? Sorry about that. So it looks pretty good. The thing that we have to remember is that all of our information that we are provided in the preview pane initially is just the top 1,000 rows from cache. As you can see on the bottom of the screen here, column profiling based on the top 1,000 rows. So we're not getting the full picture. We don't really know what the state of our data is yet because our query hasn't been evaluated in full. So when trying to look for errors in a table like this, you'd create a reference. That would be step one. To create a reference, you right-click your query and select reference here. Now, a reference means that you're taking the output of your query without duplicating any of the underlying code. So any changes made to the original query, the query that you've referenced, will automatically reflect in the query that you've just created, right? Now, I'm not going to do that here. There's really no point. This is just for demonstration, but at least now you know the steps to creating that reference and setting that up. So the next thing to do would be to select all of the columns and to see if there are errors there, right? So I'm going to press Control A on my keyboard to select all of the columns and go over to the Home tab, Keep Rows, Keep Errors. So now we see that there are 10 errors, right? And if I click on the white space beside those errors, we can see some information. We can see that notification, right? And it shows we can convert to. Those, along with wording such as can't apply operator to or cannot convert value to type, those are all issues that refer to either a value or a type, and it's typically the cell level error that you're likely to encounter. So here's a pro tip that I want to give you, because when you take a look inside the formula bar, you'll notice that table.select rows, this function, takes two arguments, the table, and optionally a list with column names. That's this part. Now, those column names are the columns that we are going to scan for errors. But what if you want to make this fully dynamic? So Power Query always checks all of the columns in your query, right? Even if columns get renamed or added later on. Well, in that case, my pro tip would be just to remove that list. Hit that check mark, and now it's fully dynamic and it will always scan all of the columns from your table. So keep that in mind. It's a good trick to know. All right, let's see. Where are we? So a quick recap, right? Errors can be divided into two groups, and they each have a very clear debugging strategy. So there are errors that break your query. Then you'd go through the applied steps, executing all of the steps one by one until you identify the problem. And then there are errors that don't break your query. Those are contained within a cell. And of course, then you can explore those by creating a reference, keeping errors to zoom in on potential problems that need your attention. Finally, there are some general best practices that we called out. Using parameters for dynamic inputs, such as data source connection strings. That's a very good practice to get started on immediately if you haven't done so already. And of course, limit nesting of functions. My advice usually is if you need to use more than 3 functions nested, stop right there, break it apart, create either a record or a let expression, whichever works for you. That will make the debugging process and of course the reading of your code so much more easy. So keep that in mind. So now we know where to start debugging, right? It's time to talk about error handling itself. Because let's face it, even with the best baby proofing, accidents can still happen. And that's why every home needs a first aid kit. So Power Query is no different, and error handling is your first aid kit. Most of the time, it's reactive, right? Like putting a Band-Aid on a wound. But other times, it's proactive, like wrapping a sprain with a Band-Aid, right? To prevent further injury. Both apply. So let's take a look and see how that works. They're very basic and very simple examples, but it's just the techniques that you need to focus on. So here we go. The first thing you need to do is, or you need to be aware of, is to handle errors where they occur. Think about the Band-Aid again, right? You've got to put it on the wound. If you put it on your elbow when the cut is on your knee, the bleeding won't stop. It's as straightforward as that. So to protect an expression, we can use the lower keyword try and prefix our expression with that. So inside the formula bar, I'm just going to add the keyword try. That looks like this, and I'll hit that tick. Now, that will always convert your value to a record, and that record has two fields. An has error field that, depending on the evaluation of the expression, returns either true or false, a Boolean value, and a value or an error field. In this case, a value because our expression didn't raise an error. Let's try that again, because here I see an error, and let's prefix this, protecting our expression, hit that check mark, and now instead of a value field, we get an error field, and that error has a record. Exactly what we would expect. We'll see that record in just a minute. So having that has error field when we protect our expression means that we can mimic the Excel is error function, right? So here's a protected expression. And we can access the value in that has error field. First thing we need to do is make sure that this part of the expression is evaluated first. So we need to wrap that in a set of parentheses. And then we can use field access or lookup, like we saw a little earlier when we explored the record expression, to access and extract that value. So in a set of square brackets, all I have to do is call that field name has error. Hit that tick again, and now we get that value, in this case, true. So what else is in our first aid kit? Well, we have a catch expression. So earlier I mentioned that we can also access the error record. Now that's where try in combination with a single parameter catch function comes in. So let's take a look at how that works. Again, catch is a keyword, so it has to be written in lowercase. So you'd write catch, not like that, but it should be English. And there we go, catch, and then a single parameter function. Now I'm just going to type that, and then we can take a look at what it does and what it means. Here we go. And I'll just hit that tick. Okay. So let's break this down. We're initializing a function with this set of parentheses right here, and we're providing a single parameter. In this case, it's called E, which is my shorthand for error. You can call this whatever you want. Then we have the goes to sign, that's this part, and then we're returning the value for E. Now you can think of E as a placeholder in case something goes wrong, right? It enables us to capture and store that error record. And that's what we're doing. So in case an error is raised, we capture that error value and we can show the record. In case no error is raised, right, a try-catch combination will return the value. So let's take a look. Let's make this a valid expression. Just going to turn this into 5 and hit that tick. And now you see that that returns 2. Okay? So let's mess that up again by making that a string. Here we go. So now we get access to that record and we see that it contains those three parts that we spoke about earlier, right? A reason, a message, and the details as well. So if you want to do some error reporting, it is helpful to have access to this. So one final technique that I want to call out is try in combination with otherwise. That lets you specify a default value or fallback value. Otherwise, again, is a keyword. So we're going to write that in lowercase. Otherwise, there we go. And now we can provide an alternative in case an error is raised. So we could say null, for example. There we go. Otherwise is a friendly way of using, is more friendly than using catch with a zero parameter function, right? So if I duplicate this, just there we go. I could get the same result if I used catch with a zero parameter function. So that would look like this. Hit that tick, does exactly the same thing. But of course, this is a little more friendly. So just a technique that you need to be aware of. Using catch with a single parameter function allows you to return the error record. Using it with a one parameter function allows you to return the error record. Using it with a zero parameter function that allows you to specify a default or a fallback value. All right, so what did we find in our first aid kit? Well, we found we found our equivalent to the isError Excel function, right? We found a method that allows us to return and access our error record, and of course, provide a default value. Now, the thing to keep in mind is that all of these techniques can only be implemented through coding, right? There's no button for you to push inside the user interface that does any of these things. However, that doesn't mean that you have to be a coder to implement error handling, but it does limit your options, right? Because when only having access or being able to use the UI, there are only two things for you to choose from, either replacing errors, which is similar to try and otherwise, where you provide a fallback or a default value, and of course, removing errors. Now note that that is a very crude method, right? And you should consider setting up some exception reporting to see what's been removed and why, in case you use that. So, Aditya, are there any questions so far?
Yes, even I was I wanted to ask you, how often should we use this try keyword in our steps? So when do you think that we should use the try option? Or maybe I will ask you properly, try and otherwise, so that we can handle those errors. But sometimes I would really like to see the errors where my data is in problems. I can tell the backend team to fix that data in the first place.
Yeah, that's a good question. I started off by saying that you need to handle errors where they occur. So that would also affect the choice in where to implement that. You can only implement or protect an expression when it can fail or when it fails. That's where you should implement that. And as to how many times you can do it, well, I'd say limitless, but don't go overboard. There are expressions that are more risky than others. So it's a balanced choice. And of course, sometimes, like you said, it is helpful to get the error because it will tell you that there's something that you need to investigate. Sometimes you just need to make a small tweak or change to resolve that, or as you said, confer with whomever provides the data to resolve that for the future. Did that answer your question?
Yes, Nishant asked it. I hope your query is solved, Nishant. Yeah, Melissa.
Awesome. Okay. So let's see where we're at. Prevention and monitoring. Okay, that's always fun. Let's head back to the Power Query Editor. Here we go.
Just to add, Melissa, I
Yeah.
think the records approach you mentioned, right? I think I would go with the records approach or even the let approach with my variable names, and my code will be self-documented in the first place. Otherwise, many times we just write our code and then after 1 month, even after 1 month, we forget, okay, why did we do this? But with records approach, it becomes quite simple that, yeah, this is the reason why I did it. And it becomes quite self-documented in the first place as well. What are your thoughts?
Yeah, especially when you name your variables right, or in this case, your field names. Your code can be self-explanatory, and of course, you can review all of the errors in one place, right? So you'd only need one try, otherwise clause, if you still wanted to implement that um, around your record expression or the value that you want to return. But yeah, I'm a huge fan of records, but naming your variables or your field names appropriately will help in documenting. I do agree on that. All right, so let's step back to prevention and monitoring. Right. So beyond patching wounds, I'd say, right? Let's talk about prevention, because error handling isn't just about fixing errors, it's also about planning, taking precautions, and trying to prevent errors from happening in the first place. So there are a few options in Power Query that you need to be aware of. The first is very obvious and is very well known among the Excel community, and that's a conditional statement using if then else, right? That allows you to change direction. It's pretty simple, but very effective. And better yet, it's a concept that most of us understand really, really well. So let's take a look at this query that I have here on the screen, right? And I'll open up the advanced editor. So I'm using our isError construct here to return a Boolean in the condition column, but we can change that, or we can use that to help in our if then else statement, right? So if whatever we are doing returns an error, we can provide an alternative. In this case, for example, we can return the value for column 1 if the value in column 2 raises an error, right? So if our, and I'm going to highlight it again, if our isError construct returns true, which it does currently, then we can provide another value. In this case, we're going to refer to the value in column 1. Else, we're just going to refer to the value in column 2. Or what is it, value 2? And I've guessed I forgot how to type, but let's see if that works. Awesome. So there you go. So this is a very simple way to change the direction, to change the flow of your query, and in this case, to change the flow of our expression. So if something falls over, we'll refer to something else. Now, as I said, this is a very simple example. The thing is that this concept can also be applied to steps at step level, right? So I've got an example of that here. I'm just going to open the advanced editor. Don't be alarmed, it's just M code. Here we go. So I've got two variables here. I've got a variable from GitHub, and I've got a variable here called fxErrorReplacer. And basically what I'm doing here is I'm testing if this returns an error for some reason. And if it does, then I've got a bit of code here. Else, I'm just going to use my initial function. So we can do this within a query as well. Now I've done this at step level, but you can do it at query level as well, right? So design your whole script, and if your script fails, then do something else. It really doesn't matter. It's up to you, whichever you need. It's just for a bit of inspiration that you can also do it at step level, right? So missing field, this is an interesting one, I think, because we've talked about how naming things, the syntax error that we referred to earlier, right? Naming things is the cause of very, very, very many step-level errors. Now, to handle them, most column and field selection functions have an optional missing field parameter that raises an error by default. So here's what that looks like. I've got a table here, and if I remove other columns, by default, this, which is not mandatory to be there, this will be applied, missing field error. Now there are two other constructs here that are possible. We can ignore any missing fields. So instead of error, we can ignore them. And there we go. And now my table is returned and any missing fields are omitted. Note that I am returning column 1 and column 4, and if I step back to my source, I have column 1, 2, and 3. There is no column 4. That's why my expression broke in the first place, and that's what I'm able to resolve now using missing field ignore. If for some reason the schema of my table is of vital importance and I need to get a column 4 no matter what, I can use, instead of ignore, I can use null. So here we go, use null. You've probably already guessed what this does. It does return the column, but because it was missing, we don't know what's there. All of the column values are now set to a null. So that's good to keep in mind. So most column and field selection functions have this option, have a missing field parameter. But it's optional, so you don't really actually know that it's there unless you go looking. Now here's an interesting thing. Recently I found out that in the May update of this year, a missing field has also been added to table.transform column types. That's quite massive and important because, let's face it, all of our queries will have that changed type step, right? And now we no longer have to resort and rely on complex workarounds to prevent them from breaking. So here's what that looks like. So I have a source table here that looks like this. There's a date column and a value column. Now, when I specify type for a date column, a customer ID column, which of course doesn't exist, and a value column, this error will be shown, the expression error. Now, in that May update, we can use that same missing field type within this function, within table.transform column types. The only real difference to all other functions that accept this parameter is that we have to specify it within options record. It looks a little different, so here's how that would look. So here's our record. It has a missing field, and in this case, we're using the missing field use null. So we get that column, customer ID, but all of the values are set to null. Of course, we can also omit that, ignoring any non-existing fields if we use missing field ignore. So again, we've created a record expression here, created a field called missing field, and assigned it the missing field ignore option, right? And that will keep that step from breaking. So that was quite an important update, or at least I really enjoyed finding that in the documentation. That's massive. All right. Okay, so there's one more thing that you need to be aware of, at least for the coders among us, right? Is when you apply field access, lookup, projection, you can mimic the behavior of missing field use null by switching to optional field access, lookup, or projection. And the trick is really simple. You just add a question mark by the end. So here's what that looks like. We go back to our missing field situation. So I have 3 columns here, column 1, column 2, and column 3. And now I'm using projection. So I'm projecting my table to one with fewer columns, and I'm requesting column 1 and column 4, for which we know doesn't exist. Now, if I append this with a single question mark, and I hit that check mark, then there we go. So that's a cool trick that always works. Awesome. And it's a simple technique to switch from required to optional projection in this case. All right. So the next thing that we need to be aware of when we are trying to protect our expressions and our queries is dealing with nulls. I mean, the null is basically the absence of a value. And it's important to understand that nulls may introduce issues further down the line. For example, nulls are removed during a non-pivot. Now, that may be undesired, and nulls may be propagated in calculations, right? So adding, dividing, subtracting something with a null, that will always yield a null as a result. So there are 3 common methods to deal with nulls. The first is to replace values. So you replace values, replacing all of the nulls in your data with something else, with something different. Then, of course, you can use a conditional statement. We've already seen that using if, then, else. So if my value is a null, then do whatever, else do what I had. Something like that. I don't know if that's English. Let me know. Anyway, the final method would be to apply coalesce using the coalesce operator. Now that's a double question mark, all right? So let's take a look. Here we go. So here we have an expression, and let's say we're adding our values. I've already applied coalesce here. That's no fun. Why did I do that? Okay, so here we go. So if I'm adding 2 values, which I'm doing right here, now this will yield a 6 in our calculation column for the first row because it has 2 values. My second row contains a value and a null, and as a result, that will always be null. I've already told you that's a double question mark, and it was already here, sadly, but we can evaluate this part of the expression to see if that returns null, and if it does, return an alternative. So to make sure it's evaluated, we're going to add another set of parentheses. Then we'll use the double question mark, that's the coalesce operator, and provide it a 0 instead. So when we now hit that tick, this now returns a null instead. Let's see, what else do we need to do? Right, values. Let's take a look at this one. Okay. So a lot of errors are generated when a value is not specific to a specific type, or otherwise the value that provided isn't of a specific type. Well, we can check a values type with a function such as value is, right? And that can be helpful to reduce the number of value type related errors. So let's take a look how that will work. So again, I have a very small sample, just a few values, and we're going to check if our value is of a number type using that expression value is. So here we go. Value.is. Open that up. Adding a comma, then we have to specify the type. In this case, we'd say type number. Again, all lowercase. Type is a keyword, number is a type. So that would be the way to write it. We're going to hit that check mark. And now we can see in our is number column that the first converted a true or resulted in a true. So 4 is considered to be of a number type, whereas a null is not of a number type. So a good thing to keep in mind is that not all types are nullable by default. So you have a type that does not include the null, and there's a type that does include the null. So if we are unhappy with the result of this returning false, then we could simply test for a nullable type. So we'll say, and then we're including that null in our type reference, right? So nullable. That's the keyword that we need to add. We'll hit that check mark again, and now because our null is included, this now also returns true. So something hopefully you can use as well. So what else is in our toolkit? Well, we can learn things about our data. Now, to be honest, if we only use the UI and we head over to the View tab, we can learn things about our data, right, by using the data preview options here. Let me switch to this query. So we can learn things about our data. Let's see, show column quality, show distribution or profile, right? We can learn things. Now, the thing is that there is also a function called table.profile that shows us information about the data that we're dealing with. As for these data preview features here, again, note that they are only shown based on the top 1,000 rows of your data unless you switch that option down below. So keep that in mind. So here we go. If we wanted to learn things, we can simply add table.profile. Wrap that around our source and hit that check mark. And now we get our column names, the min, the max values, the averages, and so on. What's good to know about the table.profile function is that it can be customized. So if there's something that you'd like to learn about your data, then you can specify some custom logic and include that in this profile. So I've created a custom profile here, and all I've done is added an error count. So this profile now returns all of the standard fields, but also always comes with an error count. That could be useful. So let's check that. It's telling me that there is one error in column 1. Let's see if that's true. So here we have one error in column 1, and the rest is looking good. Awesome. So that's something that you can take advantage of as well, creating some additional customizations to the table.profile function if you want to learn things about your data. And there's one more thing that we can do, of course, and that's exception reporting, right? If you want to monitor cell level errors, you can set up exception reporting. Think of that as baby monitor for your queries, right? Where it alerts you when something goes wrong. So earlier I mentioned that if you only remove errors, you never know what's been removed or why. Well, with exception reporting, you can capture those errors and review them. I mean, your code just might need a small tweak, right? So let's go over the basics of how you would set that up. And here's the expression. I've set it up as a record expression. We'll take a look. We'll make some sense of it together. So my goal is to list any errors that are found on each row within this table. And I want to show the reason, the message, and the details, right, for those errors. So here's how you'd set that up. And as I said, we'll unpack that together. So I've added a custom column to this table, and I've added some logic here that we can look at. So let's take a look at step 1 that's involved in that process. And in step 1, I'm just taking the current row of my table, which is a record, and I'm turning that record back into a table. That table will have 2 columns, a value column and a name column. Now that's a table, and let's zoom in on one record. So I'm just going to click on that. So I can actually show you the table. So this is what's being returned. We get all of the field names in the name column and all of the values in the value column. Having this shape, we can use the standard library function to keep all of the errors again, because this is now a table. So that's what we're doing right here. We're keeping all of the error records that were present in that table that we got from the current row, right? And when we have all of those records, we can use the construct that we saw earlier, using that try and catch a combination to get the record, get the error record, so we can take a look at all of the specifics inside. So we're adding a table, we're adding a column to our table. I'm calling that errors. And here is our try catch expression again, the expression that we explored earlier. This returns a record. Now I'm projecting that table to only keep the name and the error field because I'm no longer interested in the value. I have that, so that's good. And finally, I'm expanding it, taking the reason, the message, and the detail from my error record. And that's what we see here. So again, turning the current row of my table into a new table, keeping all of the errors from that row, transforming that to extract the error record, and extracting all of those values from that record. So the reason, the message, and the detail. So that's the basic process of how you could set up error reporting. Now, you don't have to worry too much about it. I just wanted to show you the basic steps that were involved. But within this file that I'm happy to share afterwards, and also on my GitHub side, you'll find a custom solution that does just this. So from my GitHub site, I've included an example here, right? My error report function returns a record that looks like this. It counts the errors. It brings back your data, showing all of the information, but it also has some additional options, right? You can specify key columns and scan columns, and of course, if there are any invalid values that you've provided the function, it will let you know. So awesome. Let's see. So there we go. So what did we find in our baby proofing kit? Well, we found conditional statements. We found that we could use the missing field ignore and use null options. We found some optional access that applied to projecting our tables for the Coders Among Us to lookup and selection. You can switch to optional using that question mark. We use coalesce, the coalesce operator that was a double question mark. We learned how to check a values type using the function value is. Let's see, what else did we do? Right, and we can get profiling information and set up exception reporting. You can find information on that on my GitHub site, so that's there as well. Let's see. And I think that was it. So if there's one thing I hope that you will take away from today, it's this, right? Queries need baby proofing, and errors aren't the monsters that are hiding under your bed. They're simply a signal that something needs attention. And by adopting a baby proofing mindset, you can build queries that are more resilient. I hope you enjoyed this. Please let me know. Thanks so much.
It was really interesting, the last one at least. For me, this was really cool way to understand, okay, which error is there. And I was planning to do somewhere down the line regarding how to bring all those errors, because now with the catch error, we can get those messages. So
Yeah.
that if you have got the custom function, then yeah, I would definitely love that. Uh, 2, 3 questions, Melissa. VK is asking, how do we do the data types? That has lot of challenges. How do those typecast is there? Any best practice in this regard?
Let's see. I don't think I got the question. Can you please just unmute and ask so we can talk about it?
Yeah, VK, you can unmute yourself and ask your questions.
Yeah, thanks, thanks, Aditya. So my question was, generally we have different kind of data types, right? I mean, when we are taking the sources, like we have integer, double, float, and all that kind of stuff. So is there any way that we can instrument it and automatically convert it, whether it is an M code level or wherever it is possible, right? So because that is lifting that heavy lift.
There's a bit of a challenge there with the types that you're describing, in the sense that those are type facets. So the type system in M isn't that wide, and type facets, that's something that's additional metadata that can be used by systems that receive your information from Power Query. But to Power Query, a number is just a number. It doesn't really matter how big, large, or how big or small the precision of that number is. Power Query doesn't really care about that too much. So that's a thing. There's also the amazing detect data type option within a Power Query that you'll find on the ribbon. I'm a huge fan of dissing that because it only scans the top 200 rows. That means that it's basically nothing more than a lucky guess. So if it sees the first top 200 rows as integers, but there are decimal places beyond row 200, it will tell you your column is of an integer type and you will lose precision. So when using an option like detect data types, be very sure that it guessed correctly and always validate. That's my advice. I hope this somewhat answered your question. Please let me know.
VK, you can unmute yourself and can tell. Does this answer your question?
Yes, Melissa. Yep, I like that the ribbon thing, right? So I'm just searching for those kind of a best practices where it can find. Yep. Thank you, Melissa.
And he also asked that how do we do the data quality to know which column we drop or show, and tell to the business how the source quality is.
It depends on how you define quality, because that could be a session on its own, right?
Yeah, it could be. Yeah, right. So the thing is that the typical pain point, right, for any kind of a business. So whatever that data that is coming with that fidelity, right, we don't know. So and I mean, generally it has all those Lego pieces kind of a thing, right, where it has the freshness, how good the quality of that data for that column. All those things are matters because any of those upstream systems dashboards is really don't have the data gravity just because of this data quality, right? So that's what I want to understand how best we can presumably attempt.
I kind of lifted the veil a little bit on that, VK, I think, when I showed you that there are ways to customize the profile function. So you can, when it comes to data quality, there are limited options through the UI, but you can use the table profile function and add as many custom columns and logic that you need that are vital to your business and to your scenarios at that time. I just included a simple example that counted the errors, but there are so many things you can do. If you want to count the number of appearances of a certain word within a column, for example, you could do so. It's totally up to you. If you can imagine it, you can probably build it.
Right. I mean, I'm just exploring a framework called Great Expectations. That's what I'm just looking. And I don't know how I can embed that in this Power Query. That's where I'm struggling.
Yeah. I don't know too much about that to give you an answer right now. Perhaps we.
That's fine.
I mean,
Totally fine.
send me a DM on LinkedIn, and we can discuss. We can
Sure,
explain.
definitely.
Yeah. Awesome.
Thank you.
Hey, Casey is asking Melissa, is there a way to capture column types and reinstitute them dynamically when they are lost later in the transformation?
Yes, there is. Yes, there is. There's a fun trick which Aditya and I had a lot of fun with. I think a little more than a year ago. It does require that types were present before you reinstate them.
Yeah.
And you can use value type for that. So the value type function, that's the thing that you can use. So instead of what you have is a const property in those functions, right? I'm just going to show it. Should I show it? I'll definitely show it. Hang on. Give me a second. I'm just going to share my screen again. There we go. Let's see. Power Query. There we are. So here I have a table. I have a table with a date type and a number type. So that's the thing that I have. Now, what I can do is I can break this table apart, put it back together again, and that will cause me to lose these data types. So let's do that. So I'll hit the FX to generate a manual step. And I'll just say a table to records. IntelliSense is broken again. Table dot to records. Just wrap that around it. And now I'm getting a list of records, and I can put that back again, generating a table, of course, from a list of records. So table dot from records. And there we go. And I'll hit that check mark. And now I get the ABCs 1, 2, 3s back again. So when I put my cursor before the closing parentheses and add a comma there, IntelliSense is broken, but it should show a const property there in which I can specify either field names as a list, so I can rename my columns. I can provide a table type in which I specify my column names and ascribe them a type, but I can also reuse the types from a previous step. So that will be a value type, value.type, and I can call my source step, which had those types assigned. So when I click that, there we go, my types have magically reappeared. Now, the clue to this working and being a valid solution is that the schemas need to match, obviously. You can add more fields and remove fields. You can totally do that, but it requires a bit more work and a bit more creativity. And I hope this answers the question. Did my screen show up at all?
Yeah, it is. We can see it. And this
Okay.
is what we actually discussed, Melissa, 1 year back, if I remember correctly. So this is what even I was struggling with, and I got the idea. Yeah, value type is there.
Yeah, awesome.
Just one final question. It was in the beginning. How can we use a query in the parameter? there are three options, right? So if I'm correct, we can just directly reference that query, a list of values, and it will automatically give us the values. Or is it different? I didn't write.
That's the parameter here. So I'm just going to manage parameters and show you. So there are three options here: any value, list of values, or query. That query that has to be of a list type because you're choosing options from a list. So query means a query that returns a list with values that will equally work. You can select that query and that will be the source of the values that you would be able to choose from here when specifying a current value. I'm again not sharing my screen, am I? Here we go.
No. We can see your screen. We can see your screen. Yeah. Just one more
Okay.
last thing. Table.profile slow down the query. How to improve on that? So I don't know because there are so many aggregations. I know it just dampens the performance. What I normally do is just sample the query. What steps do you follow?
Performance is always a tricky one because it depends on so many different things. So it's hard to give general advice on performance, I find. What should I say about that? The only thing that I can say is, and it's not going to be something that you like hearing, I suppose, but it's testing, trying to find alternative solutions and running through them, testing them one by one. That's the only thing that really makes sense because it really depends on the source. What type of connector are you using? How is the data coming in? Have you built and structured your query? Which types of transformations and operations have you performed? And so on. So there's so much at play that general advice is generally very hard to give when it comes to performance.
Yeah, yeah, exactly that I have realized over time that in Power Query you just cannot assume. You just have to test it, a bunch of things, and then see, okay, this really worked, and where I thought, yeah, that will be slow. So that's my takeaway as well. By the way, Melissa, there are so many people who have done so many stuff like, okay, we can automate the data, detecting the data type, right? So what is your idea? Should we do that or should we not? I know we are digressing a bit, but I wanted to get your opinion on that as well. Should we detect the automatize that detecting data type, or should we do it ourselves if we are bringing the data from Excel, or just let it handle on the server from where data is coming from?
My advice is always to detect data type because it will validate your columns and it will do so before executing your query. So for me, it's always a step that is part of my queries as it comes for automating, detecting the types, or making assumptions about the types in your columns. Always verify. I never trust detect data types, as I mentioned before. I'm always calling that out, that it's only scanning the top 200 rows of your data. Now, you can, of course, create a custom approach to try to find out what kind of value types are in those columns and expand beyond that 200 row limit. But of course, then there's a performance implication if you want to do that. And usually you know what type of values you should expect in a certain column. So the quick and easy way to work with that basically is setting it yourself. Stay in control. And if you do detect data types, don't trust, verify.
But some people mention that that is hard coding my names, right? If I make it manual, right? So maybe if there is any query, we can use it to automatically detect the data types. But I really, if you ask me, my opinion is never do that. The reason being, what if my first value is a number and the second value is a text? The better idea is to go for a text value, right? To select that column. But it just depends. It's just my opinion.
The most safe transformation, and you'll see that in the version or in the value conversion matrix as well, of course, is setting everything to text. That will work for all values except structured ones, of course.
Yeah.
Just converting everything to text, that's safe. Sure. Don't know if any transformations that follow will work, but yeah. And of course, there's also an implication for how the data is stored, right? Text generates or needs more space than numbers. So again, that isn't without risk as well, or without, what should I say, performance issues as well, potentially. Depends on the volume of data that you're working with.
All right, just last query, and I want to leave Melissa as well so that she can spend more time on her Sunday. Would you detect the data type at the beginning or at the end of the query?
I always do it as the final step in my query. No sooner than that.
Yep. All right,
So
Melissa was real. Yeah, go on.
That's why I also have detecting data types for unstructured sources always disabled, because I don't like the automatic change type step to appear out of nowhere.
Yep. I have obviously learned from you, so my detect data type goes at the end as well, unless I feel like, yeah, I need to do it at the beginning so that all of my queries are proper. So that's what I do. But yeah, it was fun, Melissa. Thank you for again enriching us with your knowledge of errors. It was really fun for me.
Awesome.
And I hope everyone enjoyed as well. All right, Melissa, if time permits, we will love to have you again here.
It will be my absolute pleasure.
Bye bye. Enjoy.
Bye, everyone.
Thank you very much.